Hi, my name is Tianzhang. I'm a research fellow and also a laboratory manager for the Renewable Energy Lab in Monash University. Now let's go have a look of our labs. This is the building of a new horizon in Monash University, and our lab is inside on level 1. This is a tornado simulator. So once it's on, the humid air will be flow upstairs, and the turbine will start and simulate how the tornadoes form. Now this is the entrance of our lab, and on the back of the office area. So all the postdocs, researchers are sitting inside, or there are also meeting rooms that people can do discussions. In our lab, we have all the consumables placed in the cabinet, so researchers are free to take. Hey Seb, how's it going?
Yes.
So now we have the lab inside. On the right-hand side, I have all the film cupboards. People can do the synthesis and the chemical reaction experiments. And on the left side, I can see these rooms, or you can go have a look at the characterization room. Hey Adam. Hey. So Adam is working on some tomography imaging system. So we normally build many home customized systems. Adam is one of the very talented PhD now. And here you got, because this is a characterization room, we have the spectroscopy, UV vis, fluorescence system, but building a solar system panel for testing the stability. Chemists who do the material synthesis, so it's mainly they are distributed in this area. They are mainly working on the material like a whole transport layer or some electron transport layer, small molecules or polymers material synthesis. Here is the fabrication lab. This is the glove box for making the perovskite solar cells. So we got Nimra is working on it. Hey Nimra. For some material sensitive to the environment, you can avoid exposure to the air and directly put it into the evaporator to make devices and then encapsulate as well. So let's make sure the sensitive materials are protected. As this lab is for fabrication, we also have some spray pyrolysis system for spraying the titanium oxide materials. So this is a 3D printer we just introduced last year for some customized system. When we have the solar cells built ready, we need to test the efficiency of it. So here is a system, we call it a high throughput solar simulator system. So basically we have a 16-channel potential state to measure the electrical current voltage characteristics of the solar cell. And then all the wires are connected to this stage. And for each stage, we have 4 cells on each. For each cell, we have 4 sub devices. And then for 16 of them can be measured at the same time under the solar simulator on top. So that really accelerate our characterization time for knowing the device is good or not. And here is the IPCE system for the quantum efficiency measurement. This is kind of a home-built system that people will be need to be trained for using it. Here is the screen printer. So it's for the dye-sensitized solar cell. And in addition to that, as you can see, this is a huge system. We call it immersion chamber solar simulator. So basically it's made of the solar simulator system on top, and the inside is the big chamber, so we can control the humidity, temperature, and then we can put the encapsulated solar cell into it, do the stress test to investigate how the solar cell can survive over time. And last, here is the heat treatment system. It's the tube furnace. For the heat treatment, we can have the different gas, like argon, oxygen, or foaming gas blowing it. This is Sapporo Coffee. So that's place we usually have the coffee and do the chat or meet friends or our collaborators. Then if you need collaboration, then this is the first place we will invite you.